all started when I was doing my PhD. So I was doing my PhD at the time, and I got in contact with an editor of one of the journals that I was trying to publish at the time. So he looked at my research. He said, it's an interesting topic, but the way you are analyzing the data, it's not the full story probably. So what I was doing, what was the typical thing to do at the time was doing structural equation modeling. And he pointed me to get a different view of the same data set, same research problem, but quite different way of explaining what is happening. So I looked into fsQCA. I had no idea what was that at the time. And since then, I started working on it, and we have published a good amount of papers since then on journals, on conferences, and with many different studies, many different types of data, and I really enjoy talking about it. It's one of the things that I don't get bored looking into, and that's what I'm gonna sort of try to present today. So all this work led to writing this tutorial paper for IGIM about 2 years ago, co-authored with Ark Woodside. So Woodside was the editor back then that pointed me towards fsQCA. So he has worked a lot on it, and we tried to put together an easy to follow step-by-step guide that hopefully makes it a bit easier to get into the method. And I will try to do the same today, but there are a lot of things on the background that I will either skip, and the method allows you to go a lot more into detail. We're not going to do that today. I think the first step is just to get your data, throw it into the tool, and try to figure out how it works and what is the outcome. And the hands-on part is the easiest way to understand, because there's a sort of switch between the classic way of thinking, the symmetrical way of thinking, towards the asymmetrical way of thinking that fsQCA is using. So the conventional measurements. So far, the classic qual and quant approaches that we are all using, they come with limitations, they come with benefits. Now, every now and then we try to think of if we can have the best of both worlds. There's an L missing there. So can we have both? I remember when I was writing about this tutorial, this wasn't the first time where people are trying to get the benefits from both qual and quant world. So what is, try to think of either you are a qual or a quant person, and it's possible to use fsQCA with both qual and quant data. We have done both. Think of what is the strength of the qual or quant, and also what are the limitations from a qual or a quant approach. So the fsQCA, it does two main things. It develops precise and explicitly measured items. So this is a very formalized process. And at the same time, they can reflect the researcher's understanding. Now, the first part, the precise and explicitly measured items, that points more to the quant part, right? We have our items that we know exactly what we are measuring. And then the second point points a bit more towards the qual part. Of course, any quant researcher should have should understand the data, but the point here is that in a classic qual study, then we are able to see the researcher's understanding into the analysis of the data as well, right? The researcher's subjectivity, because they are immersed in, they go into the context and they bring that into the analysis and the explanation of the findings. So to some extent, fsQCA allows us to do that while we're doing the analysis. And the first part that this happens is with the calibration. And I'll explain a bit later what do we mean by calibration. very simply is when we transform the data from what they are, where 0 to 1 scale to the fuzzy sets. We'll get back to that. But first, so how do we explain an outcome? And just posing here a few questions. Is it critical to identify the most important factor? Very often when we write papers, we write our discussion, I do that, for example. I have the tendency to think of this is the most important factor for this outcome. These are the 3 most important factors out of the 6 that I had in my study. But is it realistic to identify the most important factor, or only the most important factor, or how often can we do that? Also, if we're thinking of the most important factors, then is it possible that a factor is indispensable for the outcome to occur? If a factor is indispensable, does this imply that it can ensure that the outcome will be reached? So if this factor is necessary to be there, and if I have it, does it mean that the outcome will always be there? Is it possible that the existence of a factor, the presence of a factor, is enough for the outcome to occur? Questions that go quite beyond the most important factors. And why do I keep repeating the most important factors? Because this is a key difference between the classic symmetric and what we are talking today about asymmetric analysis. So research with asymmetric analysis differs from the practice of commenting only on importance. Yes, we can still comment on importance, but not only on importance, because importance can be also quite relative. So asymmetric analysis, we're looking for algorithms. So what kind of algorithms? I'll show a visualization quite later. Combination of variables. So how do our variables combine, right? Like an algorithm, like a recipe to explain an outcome. So we go beyond commenting only on importance, and we are able to identify necessary and sufficient factors for an outcome. So I was talking earlier about if a factor is indispensable, for example, for the outcome. Is it necessary, or is it sufficient? And is it one factor, or is it a combination of factors that are necessary or sufficient? So in the classic, we have our outcome here, our Y outcome, and then how do we explain an outcome if we're doing a classic regression, for example, or a classic structural equation modeling? So we have our predictors, right? And then they have some effect on our outcome. And we're calculating the net effect of each variable. So what happens here, by design, the variables compete in explaining larger parts of the variation of the outcome. Now, this is the classic symmetric thinking. So if we try to visualize how we explain the outcome through asymmetric thinking using configurational methods, and especially fsQCA. So the solutions instead, they will look a bit like this. So on the left side, I had only one solution, right? Which was the best solution that explained the largest amount of variation of the outcome. Now instead I have three solutions that includes the same variables, but different amount of them, a different version of them. We call these conditions, and maybe not all of them. So the set of variables is a predictor. The group of the variables becomes a predictor. So solution 1, solution 2, solution 3. This allows to have a synergetic effect of a set of variables on the outcome. So instead of calculating the net effect, now we're looking at the synergetic effects, how the variables, they work together to explain the outcome. They're not competing with each other. They combine in order to result to the outcome. So these combinations is also a key term that we use very often when we are describing our solution. So we are looking for combinations of conditions, not variables. We become more specific. We use the term conditions. What is the difference between variables and conditions? So male is a condition, gender is a variable, Swedish is a condition, nationality is a variable, expert is a condition, expertise is a variable. So we're looking for combinations of conditions that explain the outcome, which means a variable can have more than one conditions, right? And then different conditions of the same variable could also be part of explaining the outcome in different solutions. Condition is something a lot more specific where the variable varies. And if you try to visualize this with a Venn diagram, this is the easiest way of visualizing the combinations between the different variables and the conditions. So how do we reach to outcome B here? Outcome B occurs when, if we look at the overlaps, when A and C are present. So the area that A and C overlap explain outcome B, but also outcome B occurs when A is there, different part of B, also when C, but also when neither are there because those are different parts of B. And now if we add a few more variables here, so when does outcome B occur? When A and C are present, right? They overlap at some point over there. And then when also X and Y are present. So this leads us to the statement that the combination of A and C is sufficient, but unnecessary to explain the outcome B, because there are also other combinations of conditions or conditions to explain the outcome. We always have multiple combinations, or almost always in a typical study, you would always have more than one combination of variables that explain the outcome. So there are multiple pathways to get to the same outcome. These different combinations may explain different parts of the outcome, may refer to different cases in the outcome, but they still explain the same outcome. Now, I mentioned earlier the data calibration. So data calibration is when we transform our data from whatever they are now. They could be a Likert scale, they could be log files, they could be text data from interviews. I transform them from what they are to a 0 to 1 range. And the 0 to 1 range, because we're using fuzzy sets, and that's how the simplest thing is, that's how the tool is designed. And the calibration is important because it brings everything into sort of the same range, the 0 to 1 in this case. So calibration is very common in natural sciences, but not so much in social sciences. And by calibration, we can be a lot more precise when we are placing cases relatively next to each other. So it's a qualitative comparative analysis. So we compare between the cases. So everything is relative between the cases. So we have them all in the same range. And then we are able to make comparisons between them, which makes this process the most important one, no pun intended to my earlier, how we focus on important, but calibration, because we change the data, this is a very important part of the whole process. So how do we do this? Try to answer the question, how much does a case belong to the set? So to the fuzzy set, and what is the set? So let's say that a set is, let's try something that is measured on a Likert scale, for instance, a 1 to 7 Likert scale. And then the classic outcome is behavioral intention, right? When do I belong in the set? So if my condition, if my variable is behavioral intention, then I decide that my condition, what I'm interested in, is high behavioral intention. So then how much does a case belong to the set? Is it completely, not at all, or partially? So if it belongs completely into the set, it means that I have high behavioral intention. If doesn't belong at all at the set, it's completely out. So think of the set being the circle, allows visualizing earlier. If the case is completely in, completely out, or partially in or out, it could be a bit more in or a bit more out. So the fuzzy set, the notion of the fuzzy set, so the range, the variable being able, the values ranging from 0 to 1, allows us this flexibility to place the cases anywhere between the 0 to 1. So the full set membership completely in 1 or 0.95, more in than out. So I am more in than out, but I'm also starting to leave the set, the 66 percentile. Then I have the intermediate set membership. So I'm exactly in the middle. I'm neither completely in or neither out, exactly in the middle. More out than in. So now I'm one step out. And then the non-membership, which I am completely out of the set. Now, these values that I have used here are the values that we typically use for as thresholds to tell to our software, tell to our tool that these are the three thresholds, fully in, exactly in the middle, and fully out. And based on these three thresholds, the tool will calibrate all the values for all my cases in my dataset to bring them into the 0.1. Specifically, when I have Likert scales, and I've used a lot of, most of my studies have been with Likert scales, and we have a 7-point Likert scale. So we could, how do we do the calibration here? How do we decide the thresholds? One way to do it is following the 95th percentile, 50th percentile, and 5th percentile, as I showed earlier. But also another way to go is to set the full set membership, the intermediate and the non-membership, based on the Likert scale values, because when we look at the Likert scale, we know what it means, right? So we know what's the difference between a 6 and a 7, a 4, a 1, or 2. And let's look at an example here. So this is from our study, and then we were measuring message quality. So message quality was measured on a 7-point Likert scale, and what I'm showing here is just the mean value of from the items that we used to calculate message quality. And after the transformation, after the calibration, the values look like this. So the 6.4 on the Likert scale became a 0.97. And everything and the rest follows. So being fully in the set is as close as to 1. These are decisions that we make when we're doing the analysis, and very often you will, if you start playing with fsQCA, you will find yourselves trying different thresholds for the calibration as well, because this tool and this process allows for the data exploration to happen, and you go back to the data and you do the analysis, and maybe you need to recalibrate, because the more often, the more times you do it, the better understanding you get on what is happening in your data set. So the example that this was my first, not my first, but this was my first fsQCA paper back in 2016, an outcome of my PhD at the time. And then a few years later, I used the same study to write the tutorial paper on IGIM. Same study, same conditions, same data set, but a bit more into every step with the screenshots and so on. I've included a couple of those screenshots here, and the rest will be in the paper. So how do I like to start? And so think of this was quite a few years back. So a lot less people were familiar with the method and familiar with the way of thinking and approaching the research problem, which means that, well, it was more difficult to convince them. So I always like to start with a Venn diagram, just for the presentation of at the conceptual level of the multiple combinations of the causal conditions and the outcome. There are different ways to visualize this. I've tried different variations of Venn diagrams, and not everybody uses Venn diagrams. And now that we are all familiar, or a lot more people are familiar in information systems and marketing and management with configurational analysis, then when you mention it, then you don't necessarily need to see this visualized to understand what is happening. But back then, someone will tell me, I don't understand what you mean by multiple combinations. And then someone else will tell me, this is a very simple model. Why are you presenting a Venn diagram? We have been using Venn diagrams for years. Well, there is no novelty in that. The goal was not to add any novelty, was just to be able to communicate at an easier level. Anyway, so a question that looking at this, right? This is a classic e-commerce study, online personalization with end users being the customers that are receiving different types of personalized services. And I was looking at cognitive perceptions and affective perceptions. So how do different conditions so we had 3 on cognitive perceptions, and we tried to group as many as possible of positive and negative emotions. And how do these combine to explain intention to purchase? So here I try to summarize by one question, and user experience is in quotes because it's a very loose definition here of I use the term very loosely here just to make a point in the presentation. So is there a single best combination of user experience that will lead to high intention to purchase? So think of if I had a structural equation model here, very common thing to do still today, which is fine. Then I would end up with one solution, the best solution that explains the highest variance of my outcome, right? But how realistic is that? Well, we have, since we're all here today, I guess we agree that that's not very realistic. Yes, to some extent for a large part of the sample, but what happens with my other sample? If my R square, for instance, is 0.5 or 0.6, which would be considered nice, or even 0.7, which would be considered great if we're studying something that has been well studied. What happens with the other 30% of my sample? Do I just ignore them? They're not important to me. Well, with QCA and configurational analysis, we're able to also to go back to that sample and explain how they behave. How do we explain their intention to purchase? First step is a calibration. So I need to decide my thresholds for the calibration. And I'm using here SPSS to just calculate the percentiles, 5th, 50th, and 95th percentile. So the fully in, intermediate, and fully out. And as you will see from the values, that some are very close to the 2, 4, 6 Likert scale values that I mentioned earlier. Some are not. Now, why is that happening? Because because of the distribution of my sample. So the expectation is that if you use the 50th and 95th% and you have a normal distribution, then your 3 thresholds will be around 2, 4, and 6. If your data set is skewed, then, like for example, the highest, the weak negative and the strong negative. So I've done several studies with the questionnaires on emotions over many years, and the negative emotions were always the ones that were more skewed. So here we get that we're not that close to that 2, 4, and 6 thresholds that is sort of recommended for Likert scales. What that means? That means that the distribution actually makes a difference, but also now it becomes part of the analysis and part of the story. So now I don't sort of slightly ignore it or mention it, that distribution is like this or like that. So this influences the decisions that I have to make when I do the calibration. And and I have to explain this in the paper, why I made this decision and what does that it mean for my sample and how it affects my findings. And it might be okay to go both ways as long as you have a good reason of doing so. So this is the subjectivity of the researcher coming into the data analysis and bringing in background information, bringing better understanding of the phenomena because they collected the data, they know the sample much better, and they're using arguments to justify their choices. This is a very classic thing that we would do if we are doing a qualitative study, right? Analyzing the interviews and explaining when we stopped. So when you stop, when you have your theoretical saturation or sufficiency, you argue that, you know, I stopped hearing new things because I was there, and then I move on, right? That is very subjective, and that is fine because that's part of the strength of the analysis. And this is how our data set looks like. So after we have identified all the thresholds for all of them, for all our variables, excuse me, then here we have again message quality. I showed this example earlier, and this is the calibrated version of it. So on the left are the non-calibrated values, and then on the right are the calibrated values. I've used fsQCA software, so there's a software called fsQCA. It's freely available, and it has a nice user interface, so it's easier to use. There's also an R package for it that you can freely download, of course. And it's a bit up to you. So I've found that the R package is more powerful and less prone to bugs. But this one is obviously easier to use if you are not into typing commands and using R. This is how the my dataset looks like. So I exported a CSV file from Excel or SPSS with the first part of it. And then I did the calibration inside the fsQCA tool, and it only needed those 3 values for the threshold. There are other ways for calibration. We're not going to go there. And then what's the next step is I decide what are my variables and what is my outcome. So I select them, and then the tool will create the truth table. The next step where I have to make decisions again is during the truth table. So the truth table is simply lists every possible combination on the number of variables, based on the number of variables that I have, based on the number of conditions that I have. So if I had only 2 conditions that act as antecedents of an outcome, then the possible combinations would be 4. So here I have a few more conditions, So the truth table has more lines. So every line here is a possible combination. And the ones and the zeros, they represent presence and absence. So top left corner, message quality, it is a 1. It means that the how I read that, I say that the presence of message quality and the presence of benefits of personalization and the presence of personalization quality with all the other conditions on that line being 0, so absent. This combination appears in my dataset 99 times. So the number here refers to the frequency and tells me how many times this combination appears in my dataset. So for how many different cases this combination holds true in my dataset. Now the 0 to 1s here are constructed based on the calibrated values and the choices that I made. This is the only thing to remember now, that we have calibrated the data and the tool is using its own algorithm to create this truth table. And in addition to that, it's using those calibrated values to help me make a decision by calculating consistency. So consistency will tell me how much I can trust, how strong is this this solution, how strong is this result. The higher the better. It needs to be over certain thresholds and so on. So think of this as the parameters of fit, if you're familiar with that term coming from structural equation modeling, for example. So the tool is calculating this to help me decide what will happen for intention to purchase. So intention to purchase, as you see now, is empty. So it is our job to decide if there I will have a 1 or a 0. So the 1 is the presence, the 0 is the absence. So if I put 1 on the outcome, it means that the outcome is explained, the outcome is present. If I put a 0, it means that the outcome is not explained and is absent. How do I decide? Well, first of all, I decide, I decide by using the consistency values. I decide by using the parameters of it. That's the first. The first two, the raw consistency and the PRI consistency. But then I should also look into what the actual combinations say, because maybe a combination may seem okay in terms of numbers, but me knowing the background, I know that this can never be true. This combination can never exist in reality. So even if my variables, my truth table says that this has an acceptable consistency, if I know that this can never be true, then I can bring that into the analysis and report it accordingly when I am explaining how I made my decisions in the truth table. And when we have Likert scales and customer data, of course, it will be very hard to find such cases, but think of other type of studies when you have countries, for instance, and real life data that you know that some combinations simply cannot exist in real life. Then I have to decide the ones and zeros, and then I will do a standard analysis. So the tool will now create those multiple solutions, multiple combinations of conditions that explain the outcome. And it typically will lead to 3 solutions. I will, so this is a complex solution. This is the most complicated ones, and it has a lot of conditions. It'll be hard to read and hard to evaluate. we skip the first one. Then we have the parsimonious solution. So the second solution is typically the one that has the least amount of conditions. This is the easiest one to read, the parsimonious solution. And the conditions that appear here are what we call the core conditions. So these are conditions that cannot be left out from the analysis. And then these can be seen as most important conditions or combinations of conditions, right? And this is the third one. This is the intermediate solution. So all these three solutions, they overlap with each other because they come by simplifying the truth table and then simplifying the complex solution. So things that can be removed then are removed, and then we had the parsimonious solution. Things that are not necessarily to be removed, then we have the intermediate solution, depending on the type of assumptions that we make in the analysis. So the tool, when we are doing the standard analysis, will do this automatically in the background. There's the option to go in and make decisions and make changes in the process, but there's no need to do that when you're starting up with QCA. The thing to remember is that these are the core conditions, and these core conditions appear also in the intermediate solution, which means that the ones that do not appear in the other one are what we call peripheral conditions. And this also allows us to play in the discussion section between core and peripheral solutions and conditions. So some combinations may be more important than others because they appear in more solutions. The one thing that is not very nice is how it looks. So if you have seen some papers on QCA, they do not report the main findings in that sort of ugly manner. Maybe that is part of the appendix. We try to make that a bit nicer and easier to read. So it gets transformed, typically looking like this. So the list of conditions on the left. Then here we have the consistency, coverage, and overall solution consistency. So how strong are the results and how much do they cover of my outcome? And then instead of having that hard to read way, it has been common by now for the past 10, 15 years to use symbols, to use circles. So the circle shows the presence and the X shows the negation or the absence. So here we have transformed that list of 9 different solutions into columns. This makes it easier to identify patterns. This makes it easier to see how the different conditions sort of behave, presence or absence. And then here we're trying to tell the story. And what I typically do, I will try to move the different columns according to how I see the pattern. So here, the way I saw the pattern was that like up to the first 5, there's a lot more presence on the cognitive perceptions. And then 6, 7, 8, they're starting to sort of disappear. And then there's more focus on the affective perceptions. And the 9th one has all the cognitive perceptions absent. So this was a pattern that I saw at the time. And this is how I presented my solution. When you have a very large sample, it is common to look for patterns. When you have a very small sample, it will be difficult to find patterns, but then it's very common to go back to the cases. Because the tool will tell me for each solution, for each combination of conditions, which cases are included in that. So I know the coverage, so how much of my outcome is explained, but the tool also tells me which cases are included in that solution. This is very different from classic regression because in QCA, we don't use probabilities. We have our cases, they get attached to a truth value. So I'm not, even though I'm transforming the data, they don't lose that those initial values that they have, which allows us to go back to them and identify which ones are included in different solutions. And then I can use that as part of the discussion. I can even bring external information or context from doing the study into the discussion to explain why certain cases have this behavior. I find this very interesting, especially when there are unique cases or when there are exceptions to the rule. And also the last point to make here is that, so the raw coverage, I think of it a bit like the R-square. There's no variance, but the amount of the outcome explained. So very often, the one or two of the solutions, we have a high number of raw coverage, and that would probably be very similar to the solution that I would have gotten if I was doing a structural equation model. But then I will get a lot more other solutions with lower coverage that are not exactly that, but they are telling me that some of those conditions can be are not necessary for this number of users, or these are sufficient, so I don't need more, or I must have these ones because these are necessary. To some extent, you may be thinking also a bit of cluster analysis, the way it sort of groups my cases. There are some similarities, but there are also some differences. Now, that type of analysis, it seemed like exploratory. So I just threw all my conditions there, and I'm looking for the different combinations that they create, and that is perfectly fine. Now it's possible to go one step further and develop, formulate propositions in a similar manner like you would do with a hypothesis. So develop a proposition based on past literature and test it with QCA. So a proposition here could be customers that have a high quality personalization, high message quality, and high strongly positive emotions will have a high intention to purchase online. So looking at past literature, this is a proposition that should hold true. If this was a hypothesis, then this would be expected that it is accepted, because if I perceive that the quality of personalization is good and I like also the message that I get and I feel happy or excited, then I will have a high intention to purchase online. So I can develop this proposition, I can create it in the tool, and then I can test it and see, does this actually hold true? And the way to do it, it looks like this. So it looks like so I'm using the XY plot option of the tool to visualize, so to plot my cases. So on one axis, I will have the outcome, the intention to purchase, and the x-axis is the proposition that I just developed. The blue dots are cases in my sample. So I see here that this proposition holds true for a good amount of my sample, but not everyone. But that means that there's also a good amount of people that, even though they may have high on the proposition that I made, so the proposition, the conditions will be high, but they will not have a high intention to purchase. And if this was the actual tool and not a screenshot, you can go on every dot and see which case exactly is that in my sample. And this is the way to go back to the cases. So one dot could be one case, or could be 10 cases that are exactly on the same spot. And then this can take us back to the cases and use that also as part of the analysis. I think this is the last point. So what is the appropriate size of sample? The tool started or was developed for very small samples. very small, meaning under 30 samples, because there was an issue of the limited diversity. So we have the conditions, and then we are calculating all the possible combinations between them. But then that doesn't necessarily mean that I will have observations in real life, even though there's a possibility of combining them. It doesn't necessarily mean that this exists in real life, or even if it does, maybe I haven't observed it. So that is what is called a limited diversity issue. So the tool is trying to, the way it does the analysis, it tries to help us overcome this issue. And it can be used with very small samples and also very large. There's a nice table from Greg-Hammer et al. In 2011 that they write about the small and large N QCA approaches. So if you have a small data set, then you're aiming for a mostly inductive study, as opposed to a large N that you are testing out things more inductive or deductive. Small N could be as low as 12 cases, 15 cases. So anything under 50 is considered small. Anything over 50 is considered large. I have used it with several hundreds of users, and I know there are papers there that have thousands of users. And there were also a few papers on like analytics in QCA, but that hasn't caught up so much. So 12 to 50 could either be, for example, the list of countries, or if you have like panel data, or it could be your interviews. So our recent paper on human relations, there we had interview data, and then we transformed about a bit over 30 cases into fuzzy sets, and we conducted a QCA. Now here, when you have a very small N, consistency will be 1. When you have a large N, consistency will be lower. The coverage is expected to be very high when you have a small N, because you also want all your cases to be part of the sample. You want all your 15, 20, 30 cases. Coverage will drop the larger the sample is, and that is absolutely fine. Again, the frequency threshold also differs depending on how many cases do I have. These are decisions, so the coverage, the frequency threshold are decisions that I sort of kind of skipped today, but these are decisions that I make while I do the analysis, and I just report them accordingly. There are good rules of practice, there are rules of thumb, and so on in the literature. And the last thing that just to remember that if you have a small case, then you should always try to go back to the cases, and because that will also help you overcome the limitation of the small sample. So think of it the same as you would do in a qual study, right? It's all about the cases and how interesting they are. So you could be talking to 30 people, 50 people in an organization, but if 5 of those 50 people, they are the most interesting, they give you all the insight, then the discussion will be built around that. The very large sample, 100, 200, 500 cases, then you are looking for patterns across many cases. So you don't necessarily need to go back to the cases because you have so many cases, so it's quite difficult to go back to the cases. Thank you.
Thank you so much, Ilias. And it was a good timing as well. And it was very thoughtful and very interesting presentation. And before I open the audience for question, first I acknowledge that we do have too many audience from within our RMIT University within some other universities in Australia. And even we do have some guests from Malaysia and other countries as well. So which is very international seminar, I would say. Thank you so much. And first question, I saw somebody raised, yes, Nilofa, could you please ask the question?
First of all, thank you, Professor. And I have a question. As we are considering the combination of variables, does multicollinearity between variables can affect the result?
So if that's a good question, because I skipped that part. So if multicollinearity would be an issue in your when you're doing structural regression modeling, then it will be an issue here. So there are certain parts that are not QCA related. The multicollinearity would be based on how you have measured your variables, right? Based on the items that you have used and how they relate to each other. And you would have that issue coming from how you measure the variables and not how you are analyzing them. So, for example, if you have a reflective variable, like I did in this study, then you would have to calculate, to do reliability and validity testing for the construct. So that has nothing to do with QCA itself. So QCA, all it wants at the end is one value, so one column per variable. That's what it wants. Now, it is up to the researcher to make sure that that value for every variable is the correct one, and also what is the relation between the different variables.
Yes, got it. Thank you.
Thank you. And Samar Fatima, she has a question. Hi, Ilias. Thanks for your great presentation. I have a question. fsQCA crashes when I use more than 7 causal conditions. Did you suggest any other version of fsQCA software?
Yeah, that happens sometimes, and that's I had this issue that I couldn't see myself for you guys, so that's why I stopped sharing. The best will be to use R, because I had an issue at some point with a specific data set. It shouldn't be about the number of conditions. I think it has to do with a specific file that is that you are using. Try not to use underscores, although I'm using them.
Yeah.
And what you can do is you can insert your CSV file into R. You can export it again and try again. So I have found that as a workaround to clean the CSV file, and then QCA runs without problems. And the Mac version may crash a bit more often than the Windows version. These are all just empirics by running this so many times with many different people.
Yeah, and Fatima, yes, I have run one model with around 12 to 15 conditions, and it was quite okay. So as Ilias was saying, don't use underscores when you name the variable, and it should be fine. But my question to Ilias is 7 is the magic number of using conditions? What do you think?
Is what, sorry?
Is number 7 is
7,
the yeah, sometimes I hear that that not too many conditions should be there, and specifically I think once you told us 7 could be the one. Is it the case?
No, I don't think so. I think it's our tendency to find the best way to do things. It's our tendency as editors or as reviewers to find the best in quotes. Because we had a study these human relations. We have more than 7, and then one of the reviewers was telling us that this is too many, and you should have like a 4 to 6. And the 4 to 6 classic suggestion from Regine and others. But if it makes sense to add 2 more and it doesn't overcomplicate the outcomes, then that's fine. The numbers between 5 and 7 they are a good start because you're right on that. I agree that they can develop interesting findings, so not too complicated, but also not too simple. So you're trying to tell a story. If the findings I can come up with the findings without an analysis because I only have like 2 or 3 conditions, then I don't need QCA, I don't need configurations. Right. If my findings are so complicated that there's no way for me to tell a story and to implement anything out of them, even if each condition itself is interesting, then that's also not useful at all. But if out of the 8 or 9, one is gender, or one is like type of company that you're using, so this type of demographics, and the others are more on the fuzzy set, it means that they're adding into the story, and they're not adding into the complexity. But this 4, 5, 7 comes from how complicated the model becomes.
Sure. We have got a question from Maruf. Maruf, could you please?
Thanks, Ilias, for your nice presentation. My question is, if someone has a mediating variable in the model, do you think fsQCA is a good tool for analysis of that model?
Yes, thanks. Thank you. A very good question as well. So the version of QCA that we are using doesn't allow us to differentiate between mediators or moderators. So the tool doesn't acknowledge that. But that doesn't mean that you cannot use your mediator as another condition in the list of 4, 5, 6, 7, and still do the analysis. So there are 2 ways to go. You either, in your study, you either do your classic mediation analysis, and then you know from analysis A that this variable is a mediator, and then you take that input into your QCA. So you know that variable A out of the B, C, and D is a mediator, but then you will, if it's a mediator, that would mean that it always has to be there, right? But maybe QCA will tell you, you know what, maybe I have a combination here that I don't need mediator A. So, and this can obviously link to partial mediation that you would have from QCA. So now, instead of only saying this is a partial mediator and you stop there, well, now you know a bit more about what happens when I don't have it. And these other 3 conditions can be present and they are sufficient without my mediator. Or if it is necessary, then it's a full mediation. So this is also another way of validating the findings between 2 different, by using 2 different analyses.
Yeah, and just to add, Maruf, last month I actually ran a model where I found there are multiple moderations. So then I ran in the fsQCA and I really found that, yes, these factors actually combine together. You know, the multiple moderations actually come into effect when we run the fsQCA. So which is another way to check. Thank you so much. And I do have a question, like in one sample, Ilias, can we apply 2 different thresholds for data calibration? So for example, for one variable, we'll be using 4
Absolutely.
Yeah, all right, thank you.
Absolutely. Yeah. So the very good point, yes. Initially, I was thinking that, I think I wrote in some conference paper many years back that we try to keep the same threshold for all variables for parsimony and consistency. But like working a bit more, I realized that shouldn't matter because each variable has its own characteristics and its own understanding by the sample. So it's absolutely fine to adjust.
Yeah, thank you so much. And today we have got one more guru, which is Professor Mohammad Kudus. Me, Ilias, and Mohammad Kudus, we have written a paper. Prof, do you have any question to Ilias?
Well, I thought I can somehow skip it. Well, Ilias, thank you for presenting, and happy to see you in person. Well, from a distance. Just one query. By playing around with some data, of course, as you say that we need 3 different solutions in the parsimony, intermediate, complex. In some data, I don't have all 3. Is that something with a data peculiarity or something else could be done, should be done?
The tool doesn't calculate all three, or are they the same?
No, the tool doesn't calculate all three.
So it
Yeah, I
stops
found
at
the same problem. The parsimonious solution is not produced, and there is kind of an error message.
That it gives you the intermediate, gives you the complex.
Complex, yeah.
But the error message for parsimonious.
Yeah.
It hasn't happened to me. It
Okay.
has happened a few times that they are the same, which means that they cannot be simplified further. So I had ones that the complex was exactly the same as the parsimonious and the intermediate. And I was like, that was weird. It simply means that it cannot be simplified further. But if it cannot calculate the parsimonious, that hasn't happened. But I would be interested to figure that out. Like, if you can give me just some info on what happens.
Okay.
Because things like that are things that are not written in books, and then or not explicitly written in books. And then the only way to realize these issues is that they come up, and then you have to find a solution. So it never happened to me, and then now I'm okay. Now I have to think about it. Why it happens?
Yeah, I think what we can do between me and Mohammed is probably give you the data set and everything, so we can have a check and see.
Yeah, I can send the screenshot as well. Yeah.
Yes. Thank you. Very interesting. This is what I said. Like, this does not become boring, because you meet more people, different data sets, different stories, and then problems occur. And there are a lot more things that you can do with QCA that we didn't do in our paper, or others are not doing. But the tool has a lot more possibilities. Like what do you do with prime implicants, for example, when they tie, and a bunch of other details.
Yeah, I have another query. Do you mostly use the R package, or do you still with the software?
Still, yeah. I should switch to R, but convenience is is very high. And I saw that they had stopped developing for a few years the fsQCA software.
Yeah, that's
but now they came back with 4.1 version. So that gives me hope to stay with. Yes, that's a 4.1. Yeah. So they went back to it, I think, after the COVID break and the popularity that it got. I think that was a good motivation to go back to the original tool. But like this workaround with the data set that kept crashing, I put it in R just to throw it in and then reconstruct the CSV file. Then it sort of cleaned the data set. So I don't know, sometimes they carry around
all right. Yeah,
also, one issue is if you have long names on the variables, that's also the tool doesn't like it.
Yeah.
All right, thank you so much. I owe you a box of chocolate. If you go to India this time, I'll pass it over to you, Ilias. And I truly appreciate your time, especially in the morning in Norway. And my thanks to the audience as well. It was so lovely to see you all. And it will potentially develop some networks and collaboration as well. Thank you so much.
Thank you so much for the invitation. It was such a pleasure to see you and also talk to the whole group. Thank you, everyone, for being here. And feel free to reach out. Happy to answer any questions about it. Always a pleasure. Thank you.
Okay. Thank you.
Thank you, everyone. Thank you. Bye.
Thank you.